Hello, in this lecture we'll find out the area of the green triangle. In the drawing we have square ABCD. We know that AD equals to 4 units, so AD equals to AB equals to BC equals to CD equals to 4 units. Inside the square we have a circle, and the radius of this circle equals to 1 unit. And we also have this green triangle inside the square, and we want to find out the area of this green triangle. Okay, so first of all I will present to you a new rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and we have tangent AB to this circle, so this tangent AB is tangent to this circle at point M. Point M is the point of tangency of tangent AB with this circle. If the center of this circle is at this point, we will define the center of this circle as point O. And we also have the radius OM. So actually this radius, the radius OM, it is drawn to the point of tangency. I will repeat again. Point M is the point of tangency. Of tangent AB with this circle, and we also know that this radius The radius OM, it is drawn to the point of tendency. This is to say it is drawn to point M, that is the point of tendency. Then, according to rule number 1, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tendency. So the tangent AB is perpendicular to this radius. Why? Because this radius, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency. Therefore the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. So whenever you have a radius, like in this drawing, a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So actually we can implement rule number 1 in our drawing, because in our drawing we have this radius. We will define the center of this circle as point O, and we will define the touching point of tangent AD with this circle as point M. Actually, point M is the point of tangency of tangent AD. Again, point M is the point of tangency of tangent AD with this circle, and we have this radius, the radius OM, it is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency of tangent AD with this circle. Therefore the tangent AD will be perpendicular to this radius, the radius OM. That is to say this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees according to rule number 1, because whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees according to rule number 1. And we also know that all 4 angles that inside the square are right angles. Therefore, this angle, angle DAB, will be equal to 90 degrees. It is 1 out of 4 angles of square ABCD. Therefore, it equals to 90 degrees. So this angle equals to 90 degrees. And we will define the point of tangency of tangent AB with this circle as point N. Point N is the touching point of tangent AB with this circle, or point N is the point of tangency of tangent AB with this circle. Then we will join together points O and N by a straight line. ON is the radius of this circle, that is to say it equals to 1 unit. Why ON is the radius of this circle? Because of the fact that line segment ON starts from the center of this circle, that is to say from point O, and ends at point N, that is the point on the circle itself. Therefore ON is the radius of this circle. And here we have this radius, the radius ON. It is drawn to the point of tangency, that is to say, it is drawn to point N, that is the point of tangency of tangent AB with this circle. Therefore, according to rule number 1, this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. Okay? And we also we will define the touching point of tangent CE. This tangent, the hypotenuse of the green triangle CE, with this circle, the point of tangency will be defined as point K. Point K is the point of tangency of tangent EC with this circle. Then we will join together points O and K by a straight line. OK, line segment OK, this line segment is the radius of this circle because of the fact that therefore it equals to 1 unit, because of the fact that it starts from the center of this circle, that is to say from point O, and ends at point K, that is a point on the circle itself. Therefore OK is the radius of this circle, and this radius, the radius OK, it is drawn to the point of tangency, that is to say it is drawn to point K, that is the point of tangency of tangent CE with this circle. Therefore, the tangent EC will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So, we also have a new rule number 2. According to rule number 2, the sum of the angles, according to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. I write it down. According to rule number 2, rule number 2 states that the sum of the angles in any quadrilateral is equal to 360 degrees. So I read rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So we'll focus on this quadrilateral. So we will focus on quadrilateral MONA. On quadrilateral MONA, the sum of the angles is equal to 360 degrees. So inside this quadrilateral MONN, we have three right angles, 1, 2, 3, and the sum of three right angles is 90 times 3 is equal to 270 degrees, plus the size of the fourth angle, the size of this angle that we will define as angle X. So 270 degrees plus the size of the fourth angle, that is angle X, must be equal to 360 degrees according to rule number 2. I will repeat again. The sum of the three angles inside quadrilateral MONA is 270 degrees, plus the size of the fourth angle, that is angle X, according to our definition, must be equal to 360 degrees according to rule number 2. So here we will subtract 270 degrees from this equality, and we will get that the size of angle X, it is actually equals to 360 degrees minus 270 degrees, that is to say it equals to 90 degrees. So we found out actually that angle X is a right angle, that is to say it equals to 90 degrees. So we can change here angle X by right angle. So as you can see, all four angles inside quadrilateral MONA, inside this quadrilateral, all angles are right angles. And we also have rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. So I will read rule number 3 again. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. And actually, quadrilateral MONAN has 4 right angles, therefore we will relate to quadrilateral MOAN as a rectangle. So I repeat again. We relate to quadrilateral MOAN as a rectangle because of the fact that it has 4 right angles. And according to rule number 3, it must be at least a rectangle. Okay? And we also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. I will repeat again on rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. So we'll focus on rectangle MOAN. In rectangle MOAN, the opposite sides are equal to each other. That is to say, MO equals to AN according to rule number 4. I will repeat again. According to rule number 4, MO equals to AN because of the fact that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to AN. But it is given us the question that MO equals to 1. So we can write here that MO equals to 1. Okay? It is given us in the question that MO equals to 1. So from this equality, we will conclude that AN also equals to 1 unit. AN also equals to 1 unit. So we can write here that AN equals to 1 unit. AN equals to 1 unit. Likewise, according to rule number 4, ON equals to MA. ON equals to MA according to rule number 4. Again, ON equals to MA because there are two opposite sides and they are equal to each other according to rule number 4. But we have already found out that ON equals to 1 unit. ON equals to 1 unit. Therefore, from this equality we will conclude that AM also equals to 1 unit. AM also equals to 1 unit, or MA equals to 1 unit. Okay, we can write here that MA equals to 1 unit. So we actually found out that all the four sides of rectangle MONA are equal to each other and they are all equal to 1 unit. And we have also rule number 5. According to rule number 5, any quadrilateral that has four right angles and four equal sides must be a square. I will read rule number 5 again. According to rule number 5, any quadrilateral that has four right angles and four equal sides must be a square. And here, quadrilateral MOAN has four right angles and also four equal sides. Therefore, we will conclude from rule number 5 that quadrilateral MOAN is a square. Okay, so quadrilateral MOAN is a square according to rule number 5. Okay, quadrilateral MOAN is a square according to rule number 5 because of the fact that it has 4 right angles and 4 equal sides. Quadrilateral MOAN is a square and we also have rule number 6. According to rule number 6, the opposite side, according to rule number 6, the diagonals of a square bisects the angles of the square into 45 degrees angles. I repeat on rule number 6 again. According to rule number 6, the diagonals of a square bisects the angle of the square into 45 degrees angles. So here we have the square, MOAN, and according to rule number 6, the diagonal OA, this diagonal OA bisects this angle A, into 2 angles of 45 degrees. That is to say, this angle will be equal to 45 degrees according to rule number 6. Angle OAN or OAB will be equal to 45 degrees, and this angle also will be equal to 45 degrees. So we can write down that according to rule number 6, according to rule number 6, angle OA and OAN, this angle, or also angle OAB, it is the same. Angle OAB, this angle equals to 45 degrees. That is according to rule number 6. Okay. I will repeat again. According to rule number 6, angle OAB equals to 45 degrees. Actually, this angle OAB equals to 45 degrees according to rule number 6. You should remember that point N is located on side AB, therefore it doesn't matter at all if we relate to this angle that equals to 45 degrees as angle OAN or angle OAB, because point N it is anyway is located on the straight line AB, okay, on side AB, okay. Likewise, the diagonal CA, this diagonal CA this diagonal CA, I'll repeat again, this diagonal, the diagonal CA bisects this angle into two angles of 45 degrees. This angle will be equal to 45 degrees and this angle will be equal to 45 degrees. That is to say, angle CAB equals to 45 degrees according to rule number 6. This angle CAB equals to 45 degrees according to rule number 6. Angle CAB equals to 45 degrees according to rule number 6. Again, angle CAB equals to 45 degrees according to rule number 6. This angle CAB equals to 45 degrees. So, from the fact that both angles OAB and angle CAB, they are both equal to 45 degrees, we will conclude that those two angles are equal to each other. That is to say, angle OAB equals to angle CAB. So we can write down that angle OAB equals to angle CAB, and they are both equal to 45 degrees. Okay, so here angle OAB equals to angle CAB, they are both equal to 45 degrees. So that is to say, this angle CAB equals to angle OAB, and both angles are equal to 45 degrees. And from the fact that those two angles are equal to each other, from the fact that angle OAB is equal to angle CAB, we will conclude that diagonal CA of square ABCD passes through point O. Okay, diagonal CA passes through point O. Okay, from the fact that angle OAB equals to angle CAB, we will conclude that diagonal CA of square ABCD passes through point O. I will repeat again. From the fact that angle OAB equals to angle CAB, we will conclude that diagonal CA passes through point O. Okay? The diagonal CA of the big square ABCD, passes through point O. Okay? And we also have rule number 7. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 square root of 2 multiplied by the side, by the length of the square's side. I will repeat on rule number 7 again. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 multiplied the length of the square sides So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have square ABCD, so we have this square ABCD, and we know that the length of one side of this square ABCD equals to S units. So all the sides of this square ABCD, they are equal to S units in their lengths. then if the side of square ABCD equals to S units, so it is S units in its length, then the length of the diagonal AC will be equal to square root of 2 times ACE. Okay? So if we have this diagonal, we have this square ABCD, and we know that the length of its sides is S units, then the length of its diagonal AC will be equal to square root of 2 times S units. Okay? So we can find out the value of diagonal OA according to rule number 7. According to rule number 7, the length of this diagonal OA of square MOAN the length of diagonal OA will be equal to square root of 2 times 1, because the length of the side of square MANO equals to 1 unit. Therefore, the length of its diagonal OA, the length of diagonal OA will be equal to square root of 2 times 1, that is to say it equals to square root of 2 units. Okay, OA equals to square root of 2 units, so we can write here that OA equals to square root of 2 units. Likewise, we can calculate, according to rule number 7, the length of diagonal CA of square ABCD. So we relate to square ABCD. In square ABCD, the length of diagonal CA will be equal to the side of square ABCD that is equal to 4 units times square root of 2. Okay? I'll repeat again. So if we relate to square ABCD, then the length of diagonal CA will be equal to the length of side ABCD, the length of one side of square ABCD, that is actually 4 units, times square root of 2. So in total CA, in conclusion, CA equals to 4 times square root of 2 units, and OA, the diagonal of the small square, equals to square root of 2 units. Okay? Here, the length of CO, it will be equal to CA minus OA. Again, CO equals to CA minus OA. So I write it down. CO equals to CA minus OA. Okay, you can see from the drawing that CO equals to CA minus OA. Okay, so CO equals to CA. CA, we have already found out that CA equals to 4 times square root of 2 units. And we already found out that OA equals to square root of 2 units. So in conclusion, we will get that CO equals to 4 times square root of 2 units minus 1 times square root of 2 units. That is to say, CO equals to 3 times square root of 2 units. So we found out that CO equals to 3 times square root of 2 units. Because 4 times square root of 2 units minus 1 times square root of 2 units equals to 3 times square root of 2 units. That is to say, CO equals to 3 times square root of 2 units. So we can write here that CO equals to 3 times square root of 2 units. Okay, and we already found out that O equals to square root of 2 units. Okay, in the next step, I will present to you the last rule, rule number 8. According to rule number 8, the length of 2 tangents from a common external point to a circle are equal. So I'll repeat on rule number 8 again. According to rule number 8, the lengths of 2 tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if you have this circle and we have the external point, point P. Actually this point, point P, is an external point because point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore point P is defined as an external point. So if from the external point P we will draw 2 tangents to this circle, so the first tangent will be this tangent. This is the first tangent. And we will define the point of tangency of this first tangent with this circle as point A. And we will also, from point P, we'll draw second tangent to this circle. So this will be the second tangent to this circle. And we will define the point of tangency of the second tangent with this circle as point B. So according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So we actually drew two tangents from the common external point, point P, to this circle. The length of the first tangent is PA. The length of the second tangent is PB. And according to rule number 8, whenever you draw two tangents from a common external point of the circle to that circle, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. PA equals to PB. Why? Because from the external point, point P, we drew two tangents to this circle, and according to rule number 8, whenever you draw two tangents from a common external point of a circle to that circle, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay, this is the meaning of rule number 8. And we can actually implement rule number 8 in our drawing, because in our drawing we have the external point, point E. This point, point E, is an external point to this circle. Why? Because point E is not located in this circle nor on this circle, but it is outside this circle. Therefore, point E is an external point of this circle, and from point E we have two tangents to this circle. The first tangent is EN, and the second tangent is EK, this tangent. And according to rule number 8, whenever you draw two tangents from a common external point of a circle to that circle, then the length of those two tangents will be equal to each other. That is to say, En equals to Ek according to rule number 8. Okay? So we will define En as x, that is to say En equals to x according to our definition. So if En equals to x, then we will get that En equals to x equals to Ek. We can derive from this equality that Ek also equals to x. Ek equals to x. So Ek also equals to x. And in the next step, we will focus on the right triangle, triangle COK. This right triangle, triangle COK. On the right triangle, triangle COK, according to the Pythagoras theorem, I will repeat again. On the right triangle, triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle, triangle COK, is CO. So the square of the hypotenuse is CO squared. and it equals to the sum of the squares of the perpendiculars, that is to say it equals to OK square plus CK square. I repeat again. In the right angle triangle COK, according to the Pythagoras theorem, CO square equals to OK square plus CK square. What is the value of CO? CO equals to 3 times square root of 2 units, as you can see. So CO square will be equal to 3 times square root of 2 square. OK equals to 1 unit, therefore OK square is equals to 1 square, 1 square is 1, plus CK square. CK square is the missing variable, so we will leave it as it is. So we actually got that CO is 3 times square root of 2, so CO square is 3 times square root of 2 square, and it equals to OK squared, that is actually 1, plus CK square. So here 3 times square root of 2 square is 9 times 2. So 9 times 2 equals to 1 plus CK square. Nine times 2 equals to 1 plus CK square. So 9 times 2 is 18. So 18 equals to 1 plus CK square. Here we will subtract from this equation number 1, 1, and we will get that 18 minus 9, 18 minus 1 is 17. So 17 equals, according to equation number 1, 17 equals to CK square. So we got that 17 equals to CK square. We will take a root out of equation number 1, and we will get that CK equals to the square root of 17. CK equals to the square root of 17. So we can write here that CK equals to square root of 17 units. So in the next step we will find out the value of line segment EB. Okay, so EB, this line segment EB, it is actually equal, EB equal to AB minus AN minus NE. I'll repeat again. EB equals to AB minus AN minus NE. Okay, EB equals to AB minus AN minus NE. So actually EB, line segment EB equals to AB. We know that all the sides of the square are equal to 4 units, so AB equals to 4 units. AN, this AN equals to 1 unit, and EN or NE equals to X units according to our definition. So in total, we found out in conclusion that EB equals to 4 minus 1 minus X. 4 minus 1 is 3, so we found out that EB equals to 3 minus X units. EB equals to 3 minus X units. So I can write here that EB equals to 3 minus X units. And we know that CB is one side of square ABCD, that is to say it equals to 4 units. CB equals to 4 units. So we will implement the Pythagoras theorem in the right green triangle, triangle CB. Why the green triangle is a right angle? Because of the fact that this angle is a right angle, because we know that all the sides of a square are right angles, and this angle is one out of 4 sides of square ABCD, therefore it equals to 90 degrees, it is a right angle. Therefore, triangle CBE is a right triangle. The green triangle, triangle CBE, is a right triangle. Okay, so we will focus on the green right triangle, triangle CBE. And we will implement the Pythagoras theorem in triangle CBE. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the green right triangle is CE. Therefore, the square of the hypotenuse it equals to CE squared. CE squared, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say it equals to EB squared plus CB squared. So I will repeat again. In the right triangle, triangle CBE, the right green triangle, triangle CBE, according to the Pythagoras theorem, the square of the hypotenuse is CE squared. It equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus CB squared. So what is the value of CE? You can see from the drawing that CE equals to square root of 17 plus x. CE equals to square root of 17 plus x, so CE squared will be equal to square root of 17 plus x squared, and it equals to EB squared. EB equals to 3 minus x, so EB squared will be equal to 3 minus x squared plus CB squared. CB equals to 4 units, so CB squared will be equal to 4 squared. 4 squared is 16. So in conclusion, we found out that CE is square root of 17 plus x, therefore CE squared, it is actually square root of 17 plus x squared, and it equals to EB squared. EB equals to 3 minus x, therefore EB squared will be equal to 3 minus x squared plus CB squared. CB equals to 4, so CB squared will be equal to 4 squared. 4 squared is 16. So here we will open the brackets on both sides of equation number 2, and we will get that square root of 17 plus x squared, it is actually equals to 17 plus x squared plus 2 times square root of 17 plus x, and it equals to 3 minus x. 3 minus x squared, it is actually 9 plus x squared minus 6x plus 16. So here we have here x squared on both sides of equation number 2, so x squared will get cancelled, and here 9 plus 16 is 25, so I'll write it down. We get that 17 plus 2 times square root of 17 x equals, again, 9 plus 16 is 25 minus 6x. So here we will subtract 17 from this equation, equation number 2, and we will get that two times square root of 17 x equals to 25 minus 17 is 8 minus 6x. So here we will divide this equation, equation number 2, by 2, and we will get that 2 times square root of 17 over 2 is square root of 17 x, and it equals to 8 over 2 is 4, and minus 6x over 2 is minus 3x. So in conclusion, we got that square root of 17x equals to 4 minus 3x. Here we will add 3x to this equation, equation number 2, and we will get that square root of 17 x plus 3x equals to 4. We added 3x to this equation, equation number 2, and we got that square root of 17x plus 3x equals to 4. Here we will take a common factor x from these two expressions, and we will get that according to equation number 2, x, so we took x as a common factor, so what is left from square root of 17x after we took x as a common factor, what is left, it is actually square root of 17, and what is left from 3x after we took from it x as a common factor, what is left, it is actually 3, and it equals to 4. So here we will divide this equation, equation number 2, by square root of 17 plus 4, and we get that x equals to 4 over square root of 17 plus 3 . So we found out that x equals to 4 over square root of 17 plus 3. So here we will multiply the numerator and the denominator of this expression by square root of 17 minus 3 in order to get rid from the square root inside in the denominator. So we get that x equals to 4 times square root of 17 minus 3 over square root of 17 plus 3 times square root of 17 minus 3 . Here we will find out the value of the expression in the denominator by using the algebraic identity that states that a minus b times a plus b equals to a squared minus b squared. I will repeat again. We will find out the value of the expression in the denominator according to the algebraic identity that states that a minus b times a plus b equals to a squared minus b squared. So according to this trigonometric identity, we will find out that in the denominator we have square root of 17 plus 3 square root of 17 minus 3. So actually A is square root of 17 and B is 3. So in conclusion, we will get that x equals to 4 times square root of 17 minus 3 over a square is square root of 17 square. Square root of 17 square is 17 minus b square. B is 3, so b square is 9. So in conclusion, we get minus 9. So in conclusion, we got that according to equation number 2, x equals to 4 times square root of 17 minus 3 over 17 minus 9. Okay? So according to equation number 2, x equals to 4 times square root of 17 minus 3 over 17 minus 9 is 8. So in conclusion, we actually found out that x equals to 4 times square root of 17 minus 3 over 8. We will divide this equation. Actually, we divide only this side of the equation by 4. Equation number 2. 4 over 4 is 1, so 4 will get cancelled. And here 8 over 4 is 2. So in conclusion, we will get that according to equation number 2, x equals to square root of 17 minus 3 over 2. Okay, so we actually found out that x equals to square root of 17 minus 3 over 2. And we actually want to find out the area of the green triangle. And the area of any triangle, the formula for the area of any triangle, it is actually the base of the triangle times the height to the base over 2. I'll repeat again. The formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. So in the green triangle, the base is EB, so the area of triangle EBC will be equal to the base of the triangle that is actually EB times the height to the base that is actually BC. The height to the base is BC over 2. So I'll repeat again. The area of triangle EBC, this is the side of the area. It means the area of triangle EBC equals to the base of the triangle that is EB times the height to the base that is BC over 2. Okay? So the area of the green triangle EBC equals to EB. We've already found out that EB is equal to 3 minus x times BC. We know that BC equals to 4 units. It is one side of the square that is equal to 4 units over 2. So the area of the green right triangle EBC of the green right triangle EBC, it equals to 3 minus x over 4, 3 minus x times 4 over 2. 4 over 2 is 2, so I will write it down. So in conclusion, we found out that the area, according to question number 3, the area of the green right triangle ABC equals to 4 over 2 is 2, so it equals to 2 times 3 minus x. And we have already found out that according to equation number 2, x equals to square root of 17 minus 3 over 2 . According to equation number 2, we've already found out that x equals to square root of 17 minus 3 over 2. So we will place the value of x inside x in this equation number 3, and we will get that the area of the green right triangle ABC is equal to 2 times 3 minus x, and x is actually square root of 17 minus 3 over 2. So we found out that the area of the green right triangle ABC equals to 2 times 3 minus this expression. So here we will multiply 3 by 2 and then we will divide it by 2 in order to have a common factor with this expression, and we will get that the area of the green right triangle EBC, according to equation number 3, it equals to 2 times, so we multiplied 3 by 2, so 3 times 2 is 6 over 2 minus square root of 17 minus 3 . So here we got that the area of triangle ABC equals to 2 times 6 minus square root of 17 minus 3 over 2. 2 over 2 is 1, so 2 will get cancelled. And what is left after we cancel 2? What is left is actually that the area of the green right triangle ABC it is actually equal to 6. We will open the brackets here and we will get it is 6 minus square root of 17, and minus times minus is plus, so it is minus 3 is plus 3. So in total we got, in conclusion we got that the area of the green right triangle ABC equals to 6 plus 3 minus square root of 17. No, that is to say the area of the green right triangle ABC equals to 6 plus 3 is 9 minus square root of 17 square units. So we actually found out that the area of the green right triangle ABC equals to either 9 minus square root of 17 square units, or in terms of numbers, it equals to 4 minus 88 square units. I repeat again, we actually found out that the area of this green right triangle it equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle equals to 4 minus 88 square units. Okay? So now I'll summarize the lecture. Actually, we wanted to find out the area of this green triangle, and here we have square ABCD, and we know that square ABCD, that one side of square ABCD equals to 4 units. Inside the square we have the circle. The radius of this circle is equal to 1 unit. And we want to find out the area of the green right triangle. So, first of all, I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and you have tangent AB to this circle, tangent AB is tangent to this circle at point M. Point M is the point of tangency of tangent AB with this circle. And we have also this radius that is drawn to the point of tangency. Therefore, according to rule number 1, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tendency. So because of the fact that this radius OM, it is drawn to the point of tendency, therefore the tangent AB is perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So we actually implemented rule number 1 in our drawing. Here we have We know that here the point of tendency is point M, AD, tangent AD is tangent to this circle at point M is the point of tendency, and we have this radius that is drawn to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. And we also know that all four sides of a square are right angles, therefore this angle DAB equals to 90 degrees, and here we have this radius ON, it is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent AB with this circle, therefore according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, and we actually have also this radius, okay, it is drawn to the point of tangency, that is to say it is drawn to point of K, that is the point of tangency of tangent EC with this circle, therefore the tangent EC will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So actually here we have, I mentioned rule number 2, represented rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So if we focus on the small quadrilateral MOAN, this quadrilateral, then according to rule number 2, the sum of its angles is equal to 360 degrees. Quadrilateral MOAN has 3 right angles, 1, 2, 3, and the sum of 3 right angles is 90 times 3, it is equal to 270 degrees, plus the size of the fourth angle that is defined as angle X must be equal to 360 degrees. I repeat again, the sum of 3 angles in quadrilateral MOAN equals to 270 degrees, plus the size of the fourth angle that is defined as angle X must be equal to 360 degrees according to rule number 2. We subtract the 270 degrees from this equation, from this equality, and we got that angle X equals to 90 degrees. So we found out that this angle X is a right angle. Therefore we actually found that all the angles inside quadrilateral MOAN are right angles. And we also have rule number 3. According to rule number 3, any quadrilateral that has 4 right angles, it must be at least a rectangle, if not a square. And because of the fact that quadrilateral MOAN has 4 right angles, therefore this quadrilateral must be at least a rectangle. So we will relate to quadrilateral MOAN as a rectangle. Okay? I will repeat again. We will relate to quadrilateral MOAN as a rectangle because it has 4 right angles, and according to rule number 3, it must be at least a rectangle. And we also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. And if we focus on the rectangle MOAN, this rectangle, according to rule number 4, OM equals to AN. OM equals to AN. Okay, OM equals to AN according to rule number 4. But we know it is given us in the question that OM equals to 1 unit. OM equals to 1 unit. From this equality, we will conclude that AN also equals to 1 unit. So here, AN equals to 1 unit. Likewise, according to rule number 4, MA equals to ON. According to rule number 4, ON equals to MA. But we have already found out that ON equals to 1 unit. ON equals to 1 unit. So from this equality we will conclude that AM or MA also equals to 1 unit. MA equals to 1 unit. So we actually found out that all sides of rectangle MONA are equal to each other. They are all equal to 1 unit, and it has 4 right angles. And we have rule number 5. According to rule number 5, any quadrilateral that has 4 right angles and 4 equal sides must be a square. And because of the fact that quadrilateral MOAN, this quadrilateral has 4 equal sides and also 4 right angles, it is a square according to rule number 5. Quadrilateral MOAN is a square. Then I presented to you rule number 6. According to rule number 6, the diagonals of a square bisects the angles of the square into 45 degrees angles. Okay, so according to rule number 6, if we relate to the small square MOAN, then the diagonal OA bisects this angle A, into 2 angles of 45 degrees. That is to say, this angle equals to 45 degrees and this angle also equals to 45 degrees. Okay? That is according to rule number 6. Angle OAB, so therefore angle OAB equals to angle OAB equals to 45 degrees. This is according to rule number 6. Likewise, if we relate to the big square ABCD, and we relate to the diagonal CA, this diagonal, according to rule number 6, bisects this angle into 45 degrees angles. So this angle equals to 45 degrees and this angle equals to 45 degrees. And especially angle CAB equals to 45 degrees. According to rule number 3, angle CAB equals to 45 degrees. So here we have those two angles are equal to 45 degrees, therefore they are equal to each other. That is to say, angle OAB equals to angle CAB, and they are equal to 45 degrees. Angle OAB, this angle, is equal to angle CAB, this angle, and they are both equal to 45 degrees. And because of the fact that those two angles are equal to each other, that is to say, angle OAB equals to angle CAB, we'll conclude that the diagonal CA of square ABCD passes through point O. Okay? Because of the fact that angle CAB, this angle CAB equals to angle OAB, we'll conclude that the diagonal CA, this diagonal, passes through point O. Otherwise, if diagonal CA doesn't pass through point O, then angle CAB will not equal to angle OAB. but because of the fact that angle CAB equals to angle OAB, we will conclude that diagonal CA passes through point O, otherwise angle CAB will never equal to angle OAB. Okay? And then I presented to you rule number 7. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 units multiplied by square root of 2, the length of the diagonal of a square is equal to square root of 2 multiplied by the length of the square sides. So what is the meaning of rule number 7? The meaning of rule number 7 is if we have this square ABCD, and we know that the length of one side of square ABCD is equal to S units, then the length of its diagonal AC will be equal to square root of 2 times S. Okay? And actually implemented rule number 7 in our drawing, because in our drawing we know that the small square, in the small square MOAN, we know that one side of this square is equal to 1 unit. Therefore, according to rule number 7, the length of diagonal OA will be equal to 1 times square root of 2 units. That is to say, it will be equal to square root of 2 units. Okay, so in square MOAN, the length of the diagonal OA will be equal to square root of 2 times 1, that is to say it equals to square root of 2 units. That is the length of diagonal OA, and likewise according to rule number 7, if we focus on the big square ABCD, the length of diagonal CA will be equal to the length of the side of square ABCD. The length of side ABCD is 4 units times multiplied by square root of 2. So the length of CA, the diagonal CA, equals to the length of one side of square ABCD, that is 4 units, times multiplied by square root of 2, that is to say CA equals to 4 times square root of 2 units. So in conclusion, we found out that diagonal OA of the small square equals to square root of 2 units, and diagonal CA of the big square equals to 4 times square root of 2 units. And what is the value of CO? CO, this line segment CO equals to CA minus OA. Okay, I'll repeat again. CO equals to CA minus OA, but we already found out that CA equals to 4 times square root of 2 units and OA equals to square root of 2 units. So in conclusion, we found out that CO equals to 4 times square root of 2 units minus square root of 2 units, that is to say it equals to 3 times square root of 2 units. So CO equals to, here CO equals to 3 times square root of 2 units. Okay, then I presented to you rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and we have the common external point P, and from point P we will draw two tangents to this circle, then the length of those two tangents will be equal to each other. That is to say PA equals to PB. So whenever you draw two tangents from a common external point of the circle to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. That is the meaning of rule number 8. We implemented rule number 8 in our drawing. In our drawing, we have the external point E, and from the external point E, we have two tangents to this circle. The first tangent is tangent EN, and the second tangent is tangent EK. And according to rule number 8, the lengths of those two tangents are equal to each other. That is to say, EN equals to EK. Okay, I'll repeat again. According to rule number 8, En equals to Ek. We defined En as x, then Ek will be also equal to x, so En equals to Ek equals to x. So Ek also equals to x. On this equality we conclude that Ek also equals to x. Then we focus on the right triangle, triangle COK. This triangle, and we implemented the Pythagoras theorem in this right triangle. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CO, so the square of the hypotenuse is CO square, and it equals to OK square plus KC square. I'll repeat again, in the right triangle, triangle COK, CO square equals to OK square plus CK square. CO equals to 3 times square root of 2 units, so CO square will be equal to 3 times square root of 2 units square. OK equals to 1, so OK square is 1 square is 1, and CK square is CK square. Here 3 times square root of this square, it is 9 times 2, it equals to 1 plus CK square. We subtracted 9 times 2 is 18. So we got that 18 equals to 1 plus CK square. Here we subtracted 1 from this equation, equation number 1. 18 minus 1 is 17. So we got that 17 equals to CK square. We took a root out of this equality, equation number 1, and we got that CK equals to square root of 17 units. So we found out that CK, this line segment, equals to square root of 17 units. Okay, then we focused on the right green triangle, triangle CBE, and actually before that we calculated the value of line segment EB. From the drawing you can see that EB equals to AB minus AN minus NE. EB equals to AB minus AN minus NE. So EB equals to AB is 4 units, NA is 1 unit, and NE is x according to our definition. So EB in conclusion equals to 4 minus 1 minus x. 4 minus 1 is 3, so in conclusion we got that EB equals to 3 minus x. So we know that EB equals to 3 minus x, BC equals to 4 units, and CE equals to square root of 17 plus x units. So we focused on the right green triangle, triangle CEB, and we implemented the Pythagoras theorem on the green right triangle, triangle CBE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CE, so the square of the hypotenuse is CE square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB square plus CB square. CE, as I already told you, it equals to square root of 17 plus x, so CE square will be equal to square root of 17 plus x square. And it equals to EB square. EB equals to 3 minus x, so EB square will be equal to 3 minus x square plus BC square. BC equals to 4 units, so BC square will be equal to 16. Here we open the brackets on both sides of this equation, equation number 2, and we found out that square root of 17 plus x squared it equals to 17 plus x squared plus 2 times square root of 17 times x, and 3 minus x squared it equals to 9 plus x squared minus 6x. And we have also here plus 16. Here we have x squared on both sides of the equation, so x squared will get cancelled. And here we also know that 9 plus 16 is 25. So in total, in conclusion, we got that 17 plus 2 times square root of 17x equals to 25 minus 6x. Here we subtracted 17 from this equation, equation number 2. 25 minus 17 is 8. So here we got 8 minus 6x equals to 2 times square root of 17x. Here we divided this equation, equation number 2 by 2, and we got that square root of 17x equals to 8 over 2 is 4, and minus 6 over 2 is minus 3x. Here we added to this equation, equation number 2, 3x, and we got that square root of 17x plus 3x equals to 4. Here we took a common factor x out of these two expressions, and we got that x inside the brackets, what we have is square root of 17 plus 3 equals to 4. We divided this equation, equation number 2, by square root of 17 plus 3, and we found out that x equals to 4 over square root of 17 plus 3. And according, so here we multiplied this equation by square root of 17 minus 3, and we divided it by square root of 17 minus 3, and we got, we found out the value of this expression in the denominator according to the algebraic identity that a minus b times a plus b equals to a squared minus b squared. So according to this algebraic identity, the value of this expression, it is actually equals to 17 minus 9. So in conclusion, we got that x equals to 4 times square root of 17 minus 3 over 17 over 9. 17 minus 9, 17 minus 9 is 8. So in conclusion, we got that x equals to 4 times square root of 17 minus 3 over 8. We divided this side of equation number 2 by 4. 4 over 4 is 1, and 8 over 4 is 2. So in conclusion, we got that x equals to square root of 17 minus 3 over 2. And the area of any triangle equals to the base of the triangle times the height over 2. So the area of triangle, the green right triangle CBE equals to the base, that is BE, times the height, that is BC, over 2. And we actually found out that EB equals to 3 minus x, and BC equals to 4 units. So we got 3 minus x times 4 over 2 equals to the area of the green right triangle EBC. 4 over 2 is 2, so we got that the area of triangle EBC according to equation number 3 equals to 2 times 3 minus x. And we already found out that x equals to square root of 17 minus 3 over 2 according to equation number 2. So we put the value of x inside x in equation number 3, this equation, and we found out that the area of triangle EBC equals to 2 times 3 minus square root of 17 minus 3 over 2. Here we multiplied 3 by 2, and we divided it by 2 in order to have a common factor with this expression. And we got that the area of the green triangle EBC equals to 2 times 6 minus square root of 17 minus 3 over 2. 2 over 2 is 1, so 2 will get cancelled. And in conclusion, we found out that the area of the green triangle EBC equals to 6 minus square root of 17 plus 3. 6 plus 3 is 9. So in conclusion, we found out that the area of the green right triangle ABC equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle ABC equals to 8.8 4.88 square units. I will repeat again. The area of this green right triangle ABC equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle equals to 4.88 square units. Okay? Thank you very much.